Hello, and thank you for joining us for this informative webinar today with Titan Robotics and Infinite Materials Solutions. We're so glad that you could take the time to join us. I'm Maddie Guillory with Titan. Titan Robotics and Infinite Materials Solutions have been longtime partners, and we're excited to share how Infinite's disruptive water-soluble materials and Titan's industrial production additive manufacturing solutions are the ideal fit and work together. We're also talking about a brand new product from Infinite today, Aquasis 180. We'll start off with an overview of today's agenda for the webinar. Rahul Kasat, Titan's CEO, will give us a high-level overview of pellet extrusion versus filament extrusion and how those two technologies differ and how they can be used together on Titan's production additive manufacturing systems. Next, we'll talk about how Titan Systems and Infinite Materials Solutions' unique water-soluble materials are a perfect fit and work so well together, and some of those applications and examples of real-life prints that are being used in production applications today. Now I'll hand it over to Jeff Cernahouse at Infinite Materials Solutions for a brief introduction of their portion of the webinar. Jeff?
Hello, I'm Jeff Cernahouse, Executive Advisor and co-founder of Infinite Materials Solutions, a company focused on developing state-of-the-art, highly differentiated materials for the additive manufacturing market. First, I'm going to provide an overview of support materials and why they're important and where they can be utilized in 3D printing, and then introduce you to some of Infinite's exciting new products and a little bit of our roadmap. Specifically, I'm going to talk to you about Aquasis 180, our new product that's designed to function with engineered thermoplastics. Finally, Brandon Cernahouse, Technical Manager at Infinite, is going to provide the audience with some tips and tricks and kind of best practices for printing with Aquasis 180.
As you can see, we have a great lineup for today's webinar. Also, don't forget we will have a Q&A session at the end of the webinar, so be sure to write down your questions during the presentation. You can also put them in the chat box. We'll try to answer as many as we can at the end of the webinar and also in the chat. All right, with that, we'll start off with Rahul.
We'll start off with a high-level overview of two types of material extrusion techniques that we're going to focus on today: filament extrusion and pellet extrusion. This is probably familiar ground to many of you, but to make sure, here is a quick overview. Filament extrusion, also called fused filament fabrication or FFF, is the process of extruding a thin strand of thermoplastic material or plastic filament and then depositing the molten material layer by layer. Pellet extrusion, on the other hand, is a similar process, but instead of using filament, it uses injection molding pellets like this. As a pioneer in large format pellet extrusion 3D printing, we want to highlight several key advantages of direct pellet 3D printing. One of the biggest advantages is cost savings. Pellets are typically 10 times cheaper than 3D printing filaments. Commodity pellet materials like ABS or PLA can cost as little as $2 to $3 per pound. Another benefit to printing with pellets is the wide range of materials that can be printed. Because the material does not need to be filamentized onto a spool, you can use highly filled materials with high carbon fiber or glass fiber content. From the high performance to the highly flexible materials, we have successfully printed hundreds of grades of pellet materials. This means you're not limited to just a handful of materials that are available on the market. You can choose the right material for your application, or work with a material supplier like IMS to create custom compounds. Here you can see a small sample of some of the materials and the parts we have printed out of a variety of pellet materials. Pellet extrusion can achieve high resolution by printing with smaller nozzles, such as 0.6 millimeter, or even in some cases 0.4 millimeter nozzle diameters on Titan's Atlas platform. The nozzle size, especially on the smallest end, is highly dependent on the material and part geometry. The throughput you can achieve with pellet extrusion 3D printing is also higher compared to filament extrusion. With a larger nozzle and more liquefied material, flow rates can range from a few pounds an hour to up to 30 pounds an hour, depending on your nozzle size, material choice, and part geometry. I'm going to show you two examples of the parts printed using Titan's pellet extrusion technology. These are very unique materials. One is highly flexible material, TPE, which you cannot print with filament extrusion technology because you can't even make filaments of this. You can see the flexibility of this material. The part came out of the Atlas 3D printer. And then the second part is highly stiff material, which is made out of 30% glass fiber PEKK. Again, you can't even make a filament out of this. So again, this is a unique part that you can 3D print using Titan's pellet extrusion technology. With all the benefits of pellet extrusion, there is still an advantage when it comes to more traditional filament 3D printing, and that is surface finish. Here are some common examples of filament printed parts on Atlas platform. While we did show some high resolution pellet parts, overall filament extrusion will be the best choice for very high detail or fine resolution parts. To summarize, printing directly with thermoplastic pellets is up to 10 times cheaper than filament extrusion, up to 10 times faster than filament extrusion, and opens the door to hundreds of materials that can be 3D printed. When it comes to surface resolution, filament extrusion will have the advantage. But filament extrusion tends to be slower process with much longer print times compared to printing directly with pellets. Here you can see the incredible speed at which a pellet extrusion part is being 3D printed, reducing print times from days to just hours. When you compare the two technologies, this 40-inch layup tool only took 12 hours to print and costed less than $500 in material for carbon-filled High-Temp with pellet extrusion technology. If you had to print the same part in filament extrusion, it would have taken 120 hours to print and would cost almost $2,500 in raw materials. Well, let's talk about why we need support material. No matter what type of extrusion process you're using for 3D printing, overhangs and support structures are always a consideration, especially when you're trying to make complex geometries. Because you can't extrude molten plastic into mid-air, any part that has an overhang that is over 45 degrees will require support material structures to hold up the plastic. Support structures can be printed out of the same material as the model material as seen here. We use ABS plastic to print the top section and also same plastic to print the bottom section. But removing this support can be difficult and leave behind artifacts where the supports were manually removed. With a dual extruder configuration, such as hybrid pellet plus filament extrusion system seen here on the Atlas, support structures can be printed out of a water-soluble support material such as Aquasis 180. That material can easily be dissolved away using warm water. So this method leaves behind a better surface finish when the supports are removed and is not as labor-intensive as manually removing supports and sanding the part to get an excellent surface finish. As an industrial additive manufacturing solutions provider, Titan's production-ready systems and technology are an ideal fit with Infinite Materials Solutions' innovative and disruptive materials. Titan's mission is to enable the adoption of additive manufacturing into industrial production. And innovative materials like Aquasis 180 make that possible. In order to achieve production additive manufacturing, three elements have to come together: increasing the speed and reliability that parts can be produced, using the right material for the job, and reducing part cost. The ability to utilize high-performance, high-temperature materials with a water-soluble support material is key to produce end-use functional parts. We're helping to bring additive manufacturing into industrial production by increasing print speeds, bringing print times down from days or weeks to just hours. Thanks to Titan's Atlas industrial platform, a rigid welded steel frame, industrial CNC control system and servos, rapid travel speeds can top out at 1 meter per second. Print speeds will vary depending on your part geometry and material being used, as well as other print settings. But with pellet extrusion, you can reduce part production time significantly. Industries such as aerospace, automotive, and foundry are reducing their cycle times by bringing tooling manufacturing in-house using pellet extrusion 3D printing. Instead of spending weeks creating a large tool, they spend days and can quickly get the tool on the production line for use in composite layup molds, green sanding casting, and more. The 3D printed tools are also tough enough to withstand hundreds and in some cases thousands of cycles. Having the option to choose the right material for the job is also crucial to creating production parts. Printing large industrial parts out of high temperature material requires the right temperature environment to ensure the parts do not warp, crack, or delaminate. Most polymer materials, including ABS, polycarbonate, nylons, PEI, and PEC, require a heated chamber for successful 3D printing. This is because the consistent hotter temperature keeps the plastic stable and prevents it from prematurely cooling and pulling it on itself. This requirement becomes even more critical when you are printing larger parts. Titan's industrial heated chambers on the Atlas ensure successful printing with these high temperature materials along with high temperature Aquasis 180 water soluble material. The Atlas enclosure reaches 80 degrees Celsius, which is 176 degrees Fahrenheit, and is actively heated. So it maintains a consistent temperature throughout the chamber and for the entire printing process, a must for printing larger parts out of high-temp materials. Thanks to Infinite Material Solutions' new innovative Aquasis 180 formulation, this water-soluble material is stable at high temperatures, which is required for printing large parts out of PEI, PEC, polyketones, and more. This meets two of our requirements for the production additive manufacturing, using the right high-performance material for the part and lowering part cost by using pellet feedstock for the model material. Because we stated earlier, pellets typically cost 10 times less than traditional filaments. Titan Robotics Atlas 3D printers offer both pellet and filament extrusion on a single gantry. We call this a hybrid system because it gives customers the ultimate flexibility and control by enabling two materials to be used, taking advantage of both extrusion technologies. With the option to use Aquasis 180 either in pellet or filament form, industrial customers can choose the right method for their parts. For example, a highly filled high-temperature pellet feedstock, such as carbon fiber reinforced PEI pellets, also commonly known as High-Temp, or glass fiber filled PEC pellets, can be used as the model material in the pellet form with Aquasis 180 in the filament form to create support structures. So now that we have gone over how Titan's technology and IMS Aquasis material work together, it's time to show them in action. The versatility of this water-soluble material and Titan's industrial pellet extrusion 3D printing on the Atlas enables their use in production applications in wide range of industries from aerospace to automotive, foundry, commercial appliances, and many more. Today we will demonstrate two of those industrial uses in applications for the automotive and aerospace industries using the Aquasis material and different extrusion technologies from Titan Robotics. We'll talk about dual pellet extrusion, where we use two pellet extruders to print either a support and a model material, and then hybrid pellet and filament extrusion technology, where we use either the pellet material for the structural part and filament material for the water-soluble part. We're also going to talk about a new application that you have never seen before, 3D printing a soluble core using Titan's pellet extrusion technology. The first application we're going to talk about is the automotive duct intake that's been printed with Titan's hybrid pellet and filament extruder technology. In this case, the structural part is printed in using PEKK 30% grass-filled pellets, and then the support structure is printed with Aquasis 180 using filament. The support structure is used to print the parts, especially when you got overhangs or complex features. Once the part is completed, you just dissolve the Aquasis 180 using warm water, and you get nicer, clean, functional end part. The next application is printing soluble cores using Titan's pellet extrusion technology. Composite parts are manufactured by a variety of different traditional methods, for example, clamshell tools or patents. Producing hollow composite parts can be a huge challenge. Cost of raw materials and labor could be significant, and there is a limitation on how complex of a parts one can produce. In the recent times, industry has been using 3D printing, especially in the filament form, to print soluble core application. Even though that idea is interesting, the challenge is filament processes are still more expensive and slower, and there is a limitation of how big of a parts you can produce. So with Titan's pellet extrusion technology, we can now print Aquasis 180 in pellet form. We can print it at really high speed, and we can print larger parts for soluble core application, which is going to be a game-changing technology for a lot of different industries. Finally, we're going to talk about another automotive application. This is an engine mount. It's actually printed with Titan's dual pellet extrusion technology. In this case, both the structural material and soluble material have been printed in pellet form. We're going to introduce another great product from IMS here, Aquasis 120, which is their general purpose grade for water-soluble support material. In this case, we used glass-filled nylon, got about 30% glass fiber in it, as a structural material, and Aquasis 120 as a support material. And as you can see, this part was printed in about 8 hours, and once the printing is completed, you can dissolve Aquasis 120 using warm water and get a clean, functional part.
All right, great stuff, Rahul. Thank you so much. Now we're going to hand it over to the Infinite team with Jeff Cernhaus. Jeff.
Hi again. As I mentioned in the agenda, I'm going to introduce you all to some of Infinite Material Solutions' exciting new products, including our Aquasis 180 product. But prior to doing that, I thought I'd share with you our perspective on how we innovate at Infinite and what we strive, the types of products that we strive to create. At Infinite, we strive to create products that offer our customers the only solution to their product. By doing so, we believe that that creates exceptional customer value and intimacy. So the only statement, or the only, is it's kind of an abstract thought. So let me give you a specific example of Aquasis 180 and what we believe Aquasis 180 is the only statement in. We believe that Aquasis 180 is the only tap water soluble support material that functions with high temperature engineering thermoplastics. For example, PEEK, PEI, PPSU, and PEC. So that's a fairly compelling, the only statement. Now let me tell you about some of Aquasis' true product attributes that make it the only product that works with high temperature engineering thermoplastics. First, Aquasis 180 is unique in that it can survive chamber temperatures at up to 180 C, and that's because it's been designed to have a very high modulus at these temperatures. Second, it dissolves very readily in warm tap water, not much more than 50 to 70 degrees C. It's eco-friendly and safe to handle. Fourth, it's very easy to 3D print. You can even use it in other processes like standard extrusion or injection molding. And we've demonstrated efficacy in those types of processes and are selling commercial product into those types of applications as well. Fifth, it has excellent filament toughness. Anyone who's tried to print with filaments that are either too soft or too stiff and too brittle knows that they can cause a lot of printing problems and failures. Aquasis products have excellent filament toughness. Six, and ironically, Aquasis products have relatively low moisture absorption. Now, I'm not saying that you shouldn't take care and protect your filament and keep it sealed when you're not using it, but we've shown that when sitting out as much as a week, Aquasis in the open, Aquasis really, despite being very water soluble, picks up very little water, which is a real advantage to the technology. The material has excellent adhesion to many thermoplastics. This is, again, a very unique aspect of the Aquasis products. Both Aquasis 120 and Aquasis 180 adhere to a whole variety of different engineering thermoplastics. And finally, both products have a good thermal stability. You can print them at extruder temperatures as high as 280 C. And so that really allows a fairly broad print window and gives the customer good handles and to change the print conditions to optimize for their specific part and material. So how did we do it? Now I want to tell you how Aquasis 180 works. How does it achieve these remarkable performance attributes and work at such high chamber temperatures? The secret is Infinite's patent pending microfiber reinforcing technology. So within Aquasis 180 is a water-insoluble microfiber technology. And this microfiber technology acts to reinforce our support material at elevated chamber temperatures. What you're looking at in this chart is the modulus of 3 different materials at different temperatures. Aquasis 180, our Aquasis 120 product, and a standard competitive polyvinyl alcohol type material, PVA. And so what you see is there's a dotted line through this chart, and dotted line is at what we believe to be the minimum modulus required at temperature for a support material to function. And as you can see, PVA is far inferior, and at temperatures at 75 or 80 degrees C, it falls below this threshold. Aquasis 120, as many of you have already experienced, functions up to about chamber temperatures of 120 degrees Celsius. And what you'll see with Aquasis 180 is that it's above that temperature, almost up to 200 degrees Celsius. And so this is the secret, this is our technology, and this is why Aquasis 180 functions so well at elevated chamber temperatures. So now I'd like to tell you about where we think some key product applications for Aquasis 180. Obviously, I've already mentioned that Aquasis 180 pairs extremely well as a support material for high temperature engineering thermoplastics like PEEK, PEI, PPSU, and PAC. So that is one very key area that we believe will enable design freedom to people trying to print those materials in all kinds of different applications. However, another area we're very excited about and have had very successful beta tests in is soluble core applications. And this is when you 3D print a soluble core and then wrap it with a carbon or glass fiber layup. And then after it's cured, you wash away the soluble core material and you're left with your structural element of the continuous fiber reinforced thermoset. As I mentioned, this is a very demanding application. Oftentimes, these particular parts have to be autoclaved at temperatures as high as 170 degrees C and pressures as high as 10 bar. We've had extremely positive results with Aquasis 180 so far. And so if you have a soluble core application that you'd like to talk to us about, please do give us a contact us and we'll get you some material for trials. We also think it's going to enable a variety of end-use thermoplastic parts out of these high-temperature engineering materials in markets like aviation, automotive, and transportation, and the like, and medical markets. And then finally, we've had some early success in investment casting applications. Again, almost analogous to soluble core, but in this instance, a part is printed and then it's utilized to make an investment casting for final metal type parts or ceramic type parts. So those are some of the areas where we think Aquasis 180 is going to make a real difference. Prior to ending my session in this webinar today, I would like to take this time to introduce you to an exciting new product that we have under development and are preparing to launch, and it's our Caverna product. So what is Caverna? Caverna is a combination of a water-soluble polymer or composition and a build material, a thermoplastic material. So by carefully controlling the rheology and interfacial science, we're able to create, after washing away the support material and the material that's inside the interstices of Caverna, a co-continuous microporous foam type structure. It's analogous to like the structure of bone or coral. And what do we think are some applications for such a material? So we believe that because we have the ability to control this co-continuous pore size, this is going to allow us to 3D print, and our customers to 3D print filters. So things for filtration, both water and air type filtration, also for personal protective equipment potentially. Thirdly, for applications like footwear that may require, for example, a breathable, printable footwear that will also drain moisture. So we're in beta testing right now with Caverna, and we're looking to bring it to the broader market late in Q1 in 2021. So if you have interest in Caverna, we're likely to launch it at least in 1 or 2 materials, probably a polyolefin and a nylon grade, coming up here in early 2021. So please reach out to us and talk to us if you're interested in being a beta site tester. With that, thank you so much for joining my session of the webinar. I look forward to your feedback and collaborating with you in the future. And now I'd like to hand it over to Maddie Guillory, Chief Marketing Officer of Titan Robotics.
Thanks, Jeff. Exciting stuff there at Infinite Materials Solutions. And now we're going to stay with the Infinite team and hand it over to Brandon, who's going to talk about some tips and tricks. Brandon.
Hi there. I'm Brandon Cernahouse. I'm the technical manager with Infinite, and I have a couple of tips, tricks, and best practices for everybody today. So first of all, Aquasis 180 is a water-soluble polymer. So how do we dissolve it? We recommend using water that's 50°C or hotter. The hotter the water, the faster it's going to dissolve. And the more agitation you can get will help the parts dissolve faster and more quickly. Another tip for dissolving is, after starting, I really like to, after about 15 minutes or so, take any of the exterior supports that have started to soften and physically remove them the rest of the way. This really helps speed up the overall process and helps get to a cleaner part quicker. And it also helps get to the most solid interface layers, which are going to take the longest to dissolve. So the quicker you can get clean water to those, the quicker your part's going to clean. So after you get your part dissolved, you have some stuff left, right? You have a solution and you have some solid particles left in in the water. What do you do with them? So any of the solid material that can just go in the trash. It's not hazardous or anything. It's just the residual is going to be a solid polymer. So on a small scale, what you can do with your solution, you can either take a coffee filter or something, and you can try to filter out the remaining solid particulate matter. and then any of the dissolved polymer is safe to go down the drain. On a larger scale, if you're doing, if you've got like a big 500 liter sort of tank that you need to dissolve, you're probably going to want to send that through a non-hazardous aqueous waste stream. It's probably going to be a lot easier than trying to deal with it yourself. The next big thing for working with Aquasis 180 is moisture management. It is a water-soluble polymer, so what you really need to do, you got to keep it dry. So in between prints, we send all of our material with a resealable foil bag. I would, as soon as you're done, put it back in a bag or some other moisture-containing storage devices. A dry box with lots of desiccant or an active drying system. Any of those are going to be great for keeping your product better for longer. If it does get wet, it can be dried at about 70 Celsius, 4 to 12 hours, depending on what you're doing. Make sure there's lots of desiccant, or use something like a vacuum oven to really drive that dew point down and get the material to dry quickly. So then the last tip I have for you guys is the maximum time at temperature for Aquasis 180. After a certain period of time, this material will start to lose its solubility. It'll still print and be rigid, but if you leave it at temperature for too long, it'll be much harder to dissolve. So at 160 C, it'll take over 24 hours at that temperature before you're going to start seeing a solubility loss. At 170 C, it's closer to about 6 hours before you start seeing a drop off in solubility. And at 180 C, you're really only going to get about an hour or two at that temperature before your solubility is going to be affected. So anyway, those are the tips and tricks I have for you everybody today. Thanks for listening.
Thanks so much, Brandon. Great information there. You might have just had some of your questions answered from Brandon, but we know we have many more questions to get to for our Q&A session. You can enter your questions into the chat box. We have experts from both Titan and Infinite standing by to answer your questions, not only in the chat, but we have some panelists on hand to answer those questions live. Again, we want to put some contact information up here on the screen. If you don't have your question answered or you do want to reach out to the Titan and Infinite teams, here's how you can get a hold of us. We are ready to help you with your production additive manufacturing applications. Okay, with that, it is time for our Q&A session, and we will hand it over to the panelist of experts. Guys?